Linux OOM killer, a last resort mechanism baked deep into the kernel. Let us break down exactly how it works. Linux divides physical memory into small chunks called pages. Every time a process needs memory, it asks the kernel for pages. Normally, the kernel can satisfy these requests by reclaiming unused pages or spilling data into swap on disk. But when both RAM and swap are completely tapped out, and the kernel still cannot find free pages to hand over, the system is in an out-of-memory crisis. If nothing is done, the kernel would freeze or panic, so it needs a way to free memory immediately. Most operating systems, including Linux by default, practice memory overcommit. When a process asks for a gigabyte of memory, the kernel often says yes without actually reserving a full gigabyte of physical RAM. It makes a bet that most processes will not touch every byte they request. This dramatically improves efficiency and lets more programs run simultaneously. The trade-off is that occasionally every process tries to use its promised memory at the same time, and there is simply not enough to go around. Here is the sequence of events. A process requests a memory page. The kernel first tries to reclaim pages from its caches and inactive memory. If that is not enough, it pushes data out to swap. When even swap is exhausted and the allocation still cannot be satisfied, the kernel invokes the OOM killer. It scans all running processes, scores them, and terminates the one with the highest score. That freed memory is then used to fulfill the pending allocation and keep the system alive. Every process in Linux carries a file called OOM score inside its proc directory. The kernel calculates this score primarily from how much memory a process is using. That means its resident set size plus any swap it occupies. The more memory a process consumes relative to the total, the higher its score. Processes owned by root get a small score adjustment, and processes that have been running for a very long time also tend to have higher scores because they have accumulated more memory. The score is not static. It is recomputed at the moment the OOM killer runs, so it reflects what is actually happening right now. You are not powerless against the OOM killer. Every process also has an OOM score AJ file that you can write to. This value ranges from -1000 to +1000 and gets added to the computed score. Setting it to -1000 effectively tells the kernel to never kill this process, which is useful for critical system services. Setting it to +1000 makes a process almost certain to be killed first, which can be a deliberate choice for something like a test workload you would rather lose than your database. Many distributions pre-configure certain system processes with protective negative adjustments. This script walks through the proc file system to find every running process and prints its PID current OOM score and OOM score AJ alongside its command name. It then sorts by score in descending order so you can instantly see which processes would be killed first. The last line shows how to protect a specific process by writing -1000 to its OOM score AJ file. You need root privileges for that write. This kind of inspection is invaluable on production systems where you want to know your vulnerability before an OOM event happens. When the OOM killer does fire, it does not operate silently. The kernel writes a detailed log entry into dmesh and the system journal that includes the killed process name, its PID, its memory usage, and the full breakdown of how its OOM score was calculated. You can review this with the demis command or journal. The killed process receives a signal which it cannot catch or ignore. It is terminated immediately. Other running processes are unaffected and continue operating normally, which is the whole point. The system stabilizes, and only that one process bears the cost of the memory crisis. The OOM killer is not a flaw. It is a safety valve that keeps your Linux system running when memory gets tight. Understanding OOM score and OOM score AJ gives you real control over what survives and what gets sacrificed. Thanks for watching, and check out the next video on Awesome Linux TV to keep building your Linux knowledge.